In that, there is a term, we call it a stakeholder. And stakeholders always have concerns. So if I am a technical person and a product manager coming to me, then that person is my stakeholder who is raising a concern that the UI or the response of the API is slow. And now technical team needs to figure out why it is slow and what we can do. Product manager may or may not dictate how to solve the problem, but they will always bring their concern upward and make you aware. Are we good so far? Am I audible enough? Now, when you go out from this session, what are the 3 key takeaways I want you to go out with? The first one is that you should have a clear understanding of microservices architecture in general. The second one is lessons learned and how to deal with ambiguity. I will share some real-world scenarios with you, and then how some real-world problems are being solved using microservices architecture. Now, before we really get into microservices, if an organization is not on microservices architecture, then what are they using today? If they have any sort of APIs in their landscape. Now, if they are not using microservices, then that organization is either using monolith or SOA. SOA stands for service-oriented architecture. If any one of you have heard SOAP or REST, that is what monolith and SOA is. However, microservice is always REST. That is what preferred method is. It's not actually a method, it's a media type format, so we call it JSON. Now, what happens in these 2 approaches is that you usually have one big UI. It could be web. In today's world, it's primarily web all the time. And then you will have some services, as you can see on this block here. Now, these services will be built all together and then deployed once by itself, and then scaled all together, regardless of which one needs individual scalability. And then there will be always one large monolithic database. Now, think about any enterprise line of business application, any e-com, retail, your internal platforms, portals you are building for any customer out there in industry. What you have some sort of database there. Primarily, in most of the enterprise line of business application, there is always a relational database. Call it Oracle, SQL, MySQL, whatever you will have something like that. And then all these areas of your business, every business needs a customer. So customer is the most important entity in any database, right? You call it customer, client, whatever you call it. Well, I was working once on a healthcare, and in the domain-driven language, they were calling their customer a resident. Have you heard about AG's living? I was architecting a solution for them, and they call it resident. So in our database, table name was not customer, it was resident. In our day-to-day programming language, in our models, in our code, everywhere we were using the term resident. So that's how it works, right? So customer is representation of whoever is the consumer or the client of your application. Similarly, you will have payment, order, inventory, billing, shipping, and whatnot. All these things will be part of your entire database. Now, the next thing comes is microservice. Microservice is actually a new buzzword in the busy streets of software architecture. Now, the first time microservice term was ever used in this word was in 2011 in a software architects forum near Venice. That was the place and year when microservices was used, or the term coined first time. Now, this is 2019, and organizations are still working on it. There are so many definitions of microservice, but in general, easy way, a microservice is a set of small application components which can be independently scaled and deployed. And they are always tightly scoped and loosely coupled. That is what a microservice is. If you are building any such thing, then you are building microservice. Now, the growth of microservice industry is going very rapid. This is from market research. This image also I took it from there, and the prediction is that by 2023, the market value of microservice architecture stream altogether will be more than $33 billion. So that much investment is happening in industry today on microservices architecture. Now, when we already talked about monolith, right? As you can see here on the left-hand side of the screen. Now, when we have monolith or SOA architecture, what happens with those things is that we are not very much aware where is our context, where our domain is. And then we just happen to put anything anywhere because you are building all things together. In terms of programming language, even though you are product manager, if you know a little bit about Java or Microsoft, there is a pattern called MVC, Model View Controller. In today's world, any organization which is making or building microservices, they follow MVC pattern. Now in that, if you are building a monolith, what happens is that all your controllers are part of one process itself. You may deploy it to one service on AWS or Azure or whatever. This architecture, all these things are technology agnostic. I'm not going to talk related to any technology. If you have any such questions, I will try to answer those later on. But here, think about it that you have all these controllers. So one is customer controller, payment controller, order, inventory. All these are different controllers you have. Now think about that there is a need on payment. In monolith or SOA, since customer is the main purchaser, payment functionality can be easily put up in the customer controller if you want, and nobody will stop you. Because you are only one domain, one database, you are the only team who is working on it, and that's okay. Now this may not be very relevant example. Think about second bullet point, billing can support customer data. Billing is always on customer, what customer purchased, how much is the amount due, how much is the balance due, minimum due, last statement balance, all these things are there. Now billing can still have customer data, they can solve customer problems, means in the billing controller, you are putting some of the customer information. Order cannot be fulfilled without having an inventory check, right? Now order can have inventory logic in it. Now all these things, payment can support terms and conditions. If you ever pay any payment, let's go to pse.com. If you will pay your bill by credit card or whatever, they show a checkbox at the bottom. You need to check on it, then only your payment will be fulfilled. So that is terms and conditions. They ask you some legal text basically, which nobody reads, but people just have to check mark, right? Then only you will move forward, and your intention is to move forward. So payment can support terms and conditions. Now order can generate receipt. Let's say you walk into a T-Mobile store, and what you do, you bought something, and now you need to have the receipt. From any store, sometimes you don't need receipt, but what it does, even you go to Fred Meyer, Costco, anywhere you go, it generates a receipt, right? If you are purchasing anything, your order is being fulfilled, order domain can generate the receipts for you. Now all these things make sense as long as you are in monolith or SOA architecture. The moment you start migration or thinking towards microservices architecture, these all are anti-patterns or violation of microservices architecture. Reason why? The reason is because microservices architecture is driven by bounded context. Bounded context is a domain-driven design terminology. What it says is that your domain, whatever domain you are using, put that functionality there. Let's talk about it now. Now this inventory itself is a domain. Now terms and conditions and receipt is actually a document domain. You need a document management system. Out there, Oracle has its own implementation called XCCM, which is very good implementation to generate receipts, terms and conditions, content management like that. Now your legal can go and publish your terms and conditions text over there, and any team which is building APIs and UIs can write APIs to fetch that data and wire it up to the UI application, and different legal text on different screens, right? When you are setting up an autopay, it's a different term and conditions. When you are paying a bill one time, it's a different term and conditions. And similarly for the receipts generation. Now, if I want to transform this or migrate this SOA or monolith architecture into microservices, this is how it's supposed to look like. This is the ideal implementation of microservices architecture when you transform from monolith or SOA to microservices world. Now, as you can see here, you still have one application UI, right? Your user interface is here. This is a high-level architecture. I'm not showing many other good components in the architecture like API gateways and whatnot. So it's a very high level. And your UI will be talking to independent, multiple small microservices. If you see the color, I intentionally made it colorful for you guys so you can figure out that each color maps to its own database. This database could be SQL, NoSQL. Regardless of that, it will have its own status store. Right? Now, if you see here, let's say tomorrow, I need to build document management system. Now I have a need to print receipts, show terms and conditions. You are not going to put it anywhere here. You will think in terms of domain. You will say, okay, what domain does it represent? Whatever domains I have, it does not represent any of those. Hence, it is a document management system. It's a document domain. Hence, I will spin a new service. There could be only one API in the entire controller. You will call it document controller, and it will say get term and conditions for autopay. Just one method there, which is talking to the backend, fetching data in JSON, bringing it back to the UI, and UI shows it in a one screen. And once you put the checkbox, then only submit order or checkout button gets enabled. Think like that. Why did we do it? Somebody can argue, oh, there was just one function. Why did we do it? That's the beauty of microservices. Microservices is not about building a monolith or a bulky thing. It's all about making small services. And you do not know. Tomorrow, that document management system may evolve to get bigger. Like at T-Mobile, we have big system for document management because we have multiple prepaid, postpaid, B2B, B2C, and all these things. And then we have different terms and conditions, receipts generation, and all these things, right? So you will evolve from there. Do we have any questions so far? Yes, sir.
Just high level, please. How do microservices interface? How do they interface with like CRM or ERP systems?
So there is all these things today. Like in T-Mobile, we have SAP, ERP. So all these systems are exposing APIs. Today, whatever you see, everything is having exposed APIs. You can write code in there to expose. Even Salesforce has its own. Every system has some sort of API things out. So we have a team in T-Mobile which uses Salesforce primarily, but we do have some APIs which interacts with it and then submit the information into Salesforce. I will give you one live example. So in T-Mobile, we use Salesforce for B2B team, where I am part of now, that is business to business. We call it T-Mobile for Business. Now there, we use Salesforce very heavily to generate leads. CRM, ERP, whatever you want to call it, right? Primarily CRM. Now in that Salesforce, how do we do it? Now if somebody goes to www.tmobile.com/business, it will load our T-Mobile for Business or B2B website. You are a customer, let's say you are a small, medium, enterprise, government, whoever you are. You want to ask for some quotation. What can you do? You can go to that website, tmobile.com/business. You will fill the contact us form. And that contact us form is actually consuming Salesforce API to generate the lead in Salesforce. And then somebody will call you from backend. From our retail or sales call team, somebody will call you, say, hey, you have just put up a request there. What is your ask? Let us send you the quotation. Let us connect you with the field officer who can bring you up to speed what type of offerings we have. Did I answer your question?
If that helps. Thank you.
Okay. If anybody has anything very specific, I am willing to stay back. If you have anything, and you can always connect with me. I will see if I can answer your questions later on also. So, this is in my view, and that's a fact to a certain extent, that architecture is all about trade-offs. It is very hard to achieve perfect architecture. Whenever you take one decision, there is something, you have to weigh one thing over the other. So there are trade-offs, there are benefits. Let's talk about the benefits first, that what actually microservices architecture bring to the table in comparison to the previous one what we had. Now these are a couple of those 6 motivation factors or benefits, you can say, to change for a class. When I talk about class, it could be your model, it could be your controller class, whatever you have, wherever you are writing your logic, regardless of technology and language, there should be only one reason to change. Means you have only single responsibility. If I have a customer controller and now I'm asking you to send email to the customer. You are not supposed to change customer controller because it's only for customer. It's an email, hence you need to spin a new domain called notification. Tomorrow you may want to send messages. Third day you want to send them something else, right? Now you need to spin a separate controller, put that code there, and then let it take care of itself. That's what single responsibility is.
So would cohesive be another word for that?
Cohesive is another word for that. Thank you for bringing it up. Now speed, that is time to market. In today's world, most of the product teams can only be successful when they have faster time to market. There is no reason to hold your logic and code longer in your dev boxes. We have DevOps, we have CI/CD pipelines. You do not need long shell cycle of the code in a dev box or in some pull request sitting on GitHub or Azure DevOps or Bitbucket or GitLab, whatever you are using today. You need to push it. You need to let it gel and mesh with the rest of the production system, put feature flags and whatnot, and ship it. That's what the objective is, right? Now, how do you achieve time to market? How it is hard in Monolith, how it is hard in SOA architecture if I want to push it. Let's say I want to add customer can receive email now. I added a notification controller, what's wrong in it? Couldn't I done it there? You could have done it. The only problem is there are other people than the dev team. There is a QA team, there is a UX team. You need proper sign off to have a release. And I'm talking about proper enterprise line of business applications. Think about how many hops you have to go through before this thing really sees the light of production. Now, how would you do it in a monolith or SOA? They need to regress. If even I'm the QA manager, I will still regress your entire system because you are adding something new. I do not know what could be the ripple effect of one change. However, in microservices, since it is so small, it is bounded context, totally cohesive. Chances are if you really wrap it nicely and tested it, the other systems will not know the impact. You can keep making changes, slow by slow, and keep pushing it, and then other systems are not impacted. Scalability. Scalability is always meeting the demand of the users. As somebody said, more users, adoption, right? Now what happens with scalability is that the more users you have, you need to add more infrastructure, more power. It's not that you couldn't do it in SOA or Monolith. The only thing is there is only one box. When I say box means, let's say you did it on Azure web app. You deployed it on an Azure web service somewhere or on AWS. Once you deploy it, you had, remember that diagram, the monolith one, where you had all the different controllers and services. Now you deployed all that together, even though it could be in different availability zone and regions. You have two instances, east and west. Whenever time comes to scale payment or order, you are scaling everything actually, because it's all together, it's running in one process space when deployed on cloud or even in your private data centers. You are scaling the entire thing. However, at many times you do not need to scale everything. You have very peculiar need to scale. Let me give you one live example. When T-Mobile, recently in September, we had an Apple launch. iPhone 11, right? 11 Pro and all these new phones came. Now in that night, what do you think, where was the load on T-Mobile site or any other website? Do you think anybody was going there in that night, waking up midnight or early morning and asking us, can you change my plan and service? No. People were looking for, they were checking the inventory, even though it's a pre-order, how much we can fulfill. And the payment, agree? And then the browse page, picking the phone. Agree? You understand what I mean? How many people went that night awake midnight, holding their credit cards in hand and saying, let's do one thing, can you update my address now? Or I want to add a new line. Nobody did it. I'm not saying people cannot do it. Somebody can be in different time zone traveling, they can still do it. But that is our normal BAU. BAU means business as usual. We are always ready for it. But what we did that night, or any organization did that night, whoever was supporting such new product initiatives and launches, they will scale their payment. Make sense? They will scale their order system. They will scale their UI to be always available, because browse page has so much hit. Not everybody is going to buy. People will see. They will browse across back and forth, change colors, see how much is available, which one is what color, compare different options and whatnot, right? So our CDN, where the data is coming from, where the content is coming from, how we are placing the order, how the order will be placed and payment is processed. That is where the load was. If think about you are achieving the same thing with monolith or SOA, you need to scale entire system, even though other things could have been pretty lightweight, business as usual. But that thing can be achieved only with microservices, because in microservice, every microservice is so cohesive and tightly coupled in a way that it is one unit, and you scale only those clusters wherever it is deployed. Call it Kubernetes, Docker, whatever you have, virtual machines, Lambda, whatever you have it, regardless of that, you scale only that particular thing. Now, easier deployment. As I said, since it is just one small thing, it is easy to deploy. It also comes in terms of speed, time to market, testability, and whatnot. Problem isolation. Now, when you have one big monolith, something falls apart, it's hard to figure out what went wrong. But when it is a small, cohesive services, it is easy to find out where the problem is. And then polyglot programming. Polyglot means that you can write in multiple languages. Does it mean that I can write my customer controller in multiple languages? Answer is yes, but do not write the same customer controller in multiple languages. What it meant is that one microservices for customer domain can be in Java, other one could be in Ruby, then Golang, and then Python, and whatever you want, even C#, right? You can write different services in different languages, but do not write each function of one controller in different languages and then spin multiple controllers, just to be clear.
Yeah, call that non-redundant.
That's right. Now, there is a disadvantage of polyglot. The disadvantage is, even though this is an advantage, but not many companies, like even we at T-Mobile, do not promote polyglot programming in such a way that anybody can spin their code in whatever language they want. The reason is, it comes with a baggage. Let's say I happen to be good in Golang, and now I walk in a team who is already committed to Java Spring Boot, microservices framework, which is equally good. Now I start writing my services in Golang, and tomorrow I decide to leave. Nobody learned Golang, nobody knows what you did. And now that team cannot operate it, they cannot manage it. So you need to do a little bit comparison of it, what is the right approach, and then you go about it. Yes, sir?
Isn't the microservice should be that small to rewrite it on any other language any minute?
It's supposed to be, but usually it grows to a certain extent. And I will tell you why.
Yeah, because that's actually a principle, is to not actually change something, but just replace it.
So that is true, but what happens is there are so many NFRs. Do you know what NFR is? Non-functional requirements. Or CFRs, cross-functional requirement. You have observability on it, logging, monitoring, security, and whatnot. So when you put all these pieces together, you have pretty significant code base, and it also depends on business continuity. How effectively and how fast and sooner can you really change something to that? So I'm not saying it's not possible. This is not the principle of microservice. Certainly it is on that spirit, but make mindful decisions and educated decisions when a team adopts to polyglot programming, literally following that. Now let's talk about some pain points. What are the problems with microservices architecture? So first thing is cultural change. Cultural change means that unless a team is really ready for microservices adoption, it's not easy to adopt microservices. And I will talk more about it in detail in the another few screens upcoming. Now it is more expensive. It is expensive in a way because what your monolith is living today is living in two regions, two availability zones, east and west, and you just host it on Azure Web App or some service on AWS, and then you are done. When it comes to microservices, think about 5 or 6 different controllers, their databases you spin, and now everything's supposed to be in 2 different regions. Even though cloud is pay as you go, you can pick a little bit expensive, little bit cheaper, but now you have more to manage. You need multiple teams to manage it. If there was one team who was doing everything, I don't think the same team can manage these microservices, because microservices come with a different mindset called we build it, we own it. Now you own the entire life cycle of that microservice, from analyzing requirements to grooming to user stories, watching the sprint, dabbing it, test it, deploy it, operationalize it, maintain it, and even triage the defects. Everything is done by the very same team. Now I will talk more about it. Now increased complexity. Why complexity is increased? Because there are so many moving parts now. Multiple moving parts. Whatever was working earlier in one process space, now it is a call over HTTP. You are making so many network calls. Talk to every single other system.
So this is kind of like a global complexity is increased because in your microservices, if they're bounded, you'd almost think it would be more simple at that level.
Microservice is simple by itself.
Uh-huh.
But when you put it in the ecosystem,
Got it.
as you said, global, because one microservice cannot do anything. I'm talking about the architecture, not the microservice by itself. And less productivity. Why it is less productive? Because as I said, so many moving parts. At T-Mobile, whenever we do any new design we are coming up with, there's a new need from business, or any new planning or roadmap we are working on, we always have multiple architects from different domains coming on a call and working together. I will talk more about it later. But these are some of the pain points which I picked. Now, we learned so far what is monolith, how to migrate to microservice, how architecture will look like, what are the pain points, what are the motivations. Let's say we are really motivated and we want to go with microservices architecture. Whenever we talk about microservices architecture, now all these are different teams in blue, as you can see, payment, order, shipping, inventory, billing, and whatnot. Now, as I said earlier, each service is such a small entity in by itself, which should be owned by one team. Now, whatever number of people we have in that team, now that team will talk to other team over HTTP, REST, and then they will get the information and then pass it down and whatnot. Now, the problem in this is that many times few services can be left orphaned. Means nobody care about that. For example, shipping. Team got distributed, nobody knows what is shipping service and why they don't know about it, because there was no check-in for past few months or years in it. Because it's so stable, what you do in shipping? You just go to some third-party system, they will tell you UPS air, second day, first day, all these things, tell you the charges, do all these things, and then it's so stable. Cart service. What does cart do? Cart is add an item, delete an item, update the quantity of an item, right? Now, these are some services which are so subtle and living so quietly that nobody knows that there is a service such as cart or shipping, and then it can be left orphaned here. Nobody owns it. And let's say one fine day something went wrong in it. Now, who owns it? Nobody knows. The other problem in this space is that one service, because you disperse the team, and let's say I happen to be good with payment and order management, and I was the architect for payment and order management in T-Mobile, in my B2C team. Let's say order and billing is now owned by one team. Now if one defect comes, who owns it? Who will fix it? Or what if there was a defect in order and billing team is going to fix it? Where is the clear ownership of these things? Now that's the problem. Hence, there is another pattern to solve this problem. We call it STOSA. I wrote an article on it on LinkedIn. You can go to my LinkedIn and refer that. It's called STOSA, Single Team Owned Service Architecture. What it says is that every service, no matter how small or big, must be owned by one single team only. Having said that, can one team own two services? Answer is yes. As long as the second service is small enough and team can bear the load of it. We do not want any team to own so much which they cannot support for business continuity. Yes, Nasir?
Just trying to understand from the context of a customer. So there could be many scenarios where a customer comes in, he checks for his credit class, makes a payment. So in this kind of microservices, where is the actual data getting stored? Is it in the customer one or in the billing one? Like in monolithic way, there is one database which contains customer, his last balance and all those things. So in this kind of microservices approach, how would that data store happen?
That is coming. I will answer that later. So he was asking, like in microservice world, where the data will be stored for customer billing, who will own the data. So I will answer that. That will come. It's a good question. So here, as you can see now, every single service got a team assigned, right? So none of the service is orphaned. Now, what does this team do? This team owns the entire life cycle of that service. So if, let's say there is a product manager, now there is a business need that, you know what, now we are going to support PayPal. Now that comes from business to product envisions it. They will write the requirements, functional spec, wireframes, whatnot. Now it goes to the API team, okay, payment team architect will get involved. We are coming up with a new initiative, we need to support PayPal integration, tell me how ready you are. Many times, like in T-Mobile, we always are forward thinking. Many times we keep looking for new opportunities, how to solve pain points. I will share some of those with you later. But the idea is that none of the service, no matter how big or small it is, should be orphaned. So that is called single team owned service architecture. Now let's see microservices in action. Now let's say we are one team and we distributed our services among ourselves. We followed STOSA very nicely, clearly, and now we are trying to write microservices. Now this is one screen, everybody looks familiar to that. Now this screen shows that how your APIs are being used, microservices. As you can see, there are total 7 sections on the left hand side on UI. You can see the red boundary. There are 7 sections. To pull data for those 7 sections, there are actually 14 microservices on the screen, as you can see. So there are different backends systems and domains involved. Data is pulled from those backend domains into one service here, as you can see, UI composition microservices. And then that UI composition microservice is rendering information onto your UI screen. Now, what do we call it? Actually, at T-Mobile also we have the same thing. We have almost something similar because that's how industry is using microservice. Now, there are 2 flavors to microservices when you go that way. One is called Capability API. Capability API is, let's say, we need to pull your billing information. Now, when I'm pulling your billing information, I say, get billing info, and I'm passing your MISDN. MISDN means phone number. MISDN is a telecom term for phone number. So I say, get billing information, and I pass a phone number. Now it will go to the billing system and then bring that information back. Since it is coming from the domain, now that domain speaks in a very specific language which only a microservice API understands. But UI does not understand that. That is first thing. Second thing is, to get one thing done, we need to fire up multiple calls. Think about this whole thing, rendering here. If you come here, this has one thing and it's referring to 3 or 4 my backend API. Means you are firing up multiple calls, maybe to same domain or to different domains to pull the data. And then you are rendering it. So there is a capability API and then there is an experience API. Experience means your user interface, your user experience, your UI. So what you do, UI cannot fire multiple calls to backend. UI will fire only one call. That one call goes to your microservice, experience API, and then that will fire multiple microservice API calls to backend, get the data, aggregate it, and then massage it, scrub it if needed, and then give it back to UI. This thing is also known as scatter and gather pattern or aggregator pattern, where you fire multiple calls, that call transforms into multiple calls in the backend, brings back data, massage it, scrub it as needed, and give it to UI. Many times it does not need to do it. UI can make sense out of that data points and then render it on UI as needed. So this is one screen I have shown you. This is Amazon's view. It's an old design though. Let me show you something real from our T-Mobile. So I am now with B2B team, T-Mobile for Business. We have small, large enterprise, government customers. Now this is a screen, a real customer data. As you can see, the bill is in like $150,000 plus. Now this is a real screen. If you see here, there are over a dozen microservices call happening across 6 domains to render this screen in real. We are making over a dozen microservice calls across 6 domains to render this whole screen here. Now, when we do all these things, now, as you can see, you are having more number of microservices. There are so many moving parts. Now, one of the vulnerability of microservice architecture is that it's bound to fail. The more services you have, you are more prone to fail. Services will fail. Now, the thing is that how do you deal with service failures. Usually your interaction path will look like this. You have your service. Let's say this is your experience service, as I said. Now this experience service is talking to multiple backend service, as I shown earlier, like in Amazon or T-Mobile, which is firing up against multiple domains, or same domain but calling multiple data, then get all that information together and then show it on the screen, right? Now, what can happen is if one service fails. So let's say service A started failing. Now, since that was coming from our service and this service failed, the drawback of that is that everything will start failing. Make sense? You understand at a high level? This is how the flow is supposed to be, because something started failing and I was looking for every service should be success. So I started failing here, and when I fail here, this customer failed, and then this customer also failed, or whatever customer is there, they will all fail. Make sense? Do we have any questions so far? Yes, sir.
You may cover this. Can you go back to the previous slide?
Sure.
So in this you said that you're pulling 6 services. So shouldn't it happen that, let's say if one of the service fails, that at least you'd show the 5, and the 6th one you wouldn't show it?
I'm coming to that.
Okay.
But yes. But it's not that easy as you said. But yes, that's right.
That's a good question.
No, it is certainly. No, I'm coming to that. If you noticed, I'm connecting dots. That's how I laid out the presentation. I'm connecting dots, one after the other. And if you will have any questions which are not unanswered or comes later to your mind, feel free to message me on LinkedIn, or from my blog you can reach out to me. That comes to my personal email, and then I will address it, or we can work on a phone call for that. So I'm coming to that. As I said, I'm connecting dots. Now, how do we respond to failures, right? Now, first thing is that how do you respond to any failure? So first thing is that the response to a failure must be understandable. That is the first thing, that whatever response you have, it has to be understandable. So when we work with any API team, let's say product manager came with some sort of spec, they said, okay, we want this, this, this. They represent the customer. Many times they own the wireframes and the functional flows, and then sometimes technical aspects as well, whatever it is. There is always a swagger, the API contract involved. In that API contract, you will define that what this service is supposed to do, right? Now, in that case, adhere to the API contract, do not violate it. That's the first thing. How do you respond to a failure? So if there is anything, and you are telling, and we agree upon that if something is wrong, you will give me this error message, then always show that error message upfront, and don't surprise the consumer. That consumer could be your experience API, which is fired against multiple backends, as you were referring to. Now, so do not violate. That's the first thing. Response to a failure has to be understandable. No matter what, if it failed, that's okay, it failed, but tell me something which I can understand. That's the first thing. Many times I notice in industry is, we still face those pain points at times. Why it is failing, nobody knows. And then you get in the triage loop. You get on the conference calls and Splunk logs and whatnot, and then you figure out why it failed, what was the message, and what we should have shown, right? So that's the first thing. Second thing is reasonable. Now, indicative to what actually happened, right? So let's say you have a simple service, math service, you are doing what is n1 plus n2, 2 plus 2 equal to 4. Let's say I passed 2 plus a character, and it showed me something like red. That doesn't make sense. As I said, it has to be understandable. So there should be some agreeable contract that don't show me it's red or something, whatever comes to their mind. Show me what went wrong, right? Now that is, please try again later, or invalid input, or whatever it is. So that is, it has to be reasonable. Now this is the most important one, predictable. Many times when we are working on APIs, we have our own understanding. We predict the output. Think about it. You are going to log in to a website. You entered incorrect password. What does it do? It says username or password is wrong. Isn't it right? Yes? You are entering credit card number. It will tell you up front credit card number is invalid. Yes? That is what? That is predictability. You know what you are expecting. You predict that. So predictability is the most important characteristic of microservice. Now what happens here is that planned response for a given set of circumstances. Let's say 2 plus 2 equal to 4. But what is 2 divided by 0? Right? So it should give you invalid request or some sort of arithmetic exception like divide by 0 exception, which transforms into a user-friendly message rather than giving you some random number like this and the next time some other random number. Right? So that is what predictability is. Now, since it is a so important characteristic, predictability does not mean garbage in, garbage out. Always remember that. That is predictable. Garbage in, garbage out. We always say that, right? But predictability means garbage in, invalid request. Right? There is a saying, do not trust any input from anybody. Do you know that? There is always client-side validation and then server-side validation. You know that? Most of the systems run today that they will only validate your credit card number on the front end only. Oh, you are Visa, you have 16 digits. Social Security, you have these many digits. But when it goes to backend, backend doesn't care. Somebody can test that API by Postman and pass whatever junk you want, right? So never trust the input. So it's not garbage in, garbage out. It's garbage in and then invalid request. So the sooner you send that response back. Now think about it. We took that input, your phone number with 4 or 5 digits instead of 10, and we run all the way back to our billing system. And then billing system kick us out. How expensive it is. First step, UI should have stopped me then and there. Let's say I pass that. How do I pass it? Hit API from Postman. That's how API testing happens. White box testing, right? Now I hit by Postman. Postman also said, okay, good. Let me go to the lower environment, QA or dev instance of the billing and hit it. Now billing kicked me out. What is this? Invalid telephone number. Must be 10 digits, right? So predictability is garbage in, invalid request. So validate your input. That's what it is. Now let's see something that how do you handle unpredictable responses? This is Netflix. Everybody knows it. If you do not have Netflix, switch to T-Mobile. T-Mobile offers free Netflix. Netflix is on us on T-Mobile. So handling unpredictable failures, Netflix. And I will share some more examples with you in real world. Now what happens here? I have actually seen it in real, okay? So what happens is, if you see, whenever you load Netflix, it has different blades on the screen. Is that it right? Continue watching for this profile name. There are multiple profile, mom, dad, kid, right? This was my younger daughter's name, so I just put profile name there. But this is a real screen from my Netflix. Now watch it again. Everyone is watching. Trending now. International movies, TV shows, drama. It shows all these different blades on Netflix. If you will notice, it's very dynamic. Next day you come, it will show something else. So that's how it is, right? Now, how do you handle unpredictable failures? Now, first thing is that what is unpredictable actually? Unpredictable is when you are not expecting a service to be down, but it stopped responding. Does it mean I cannot wait for response? Of course, there could be retry logic there. There could be timeout, but how long do I wait? I'm expecting this service to respond in 100 milliseconds. Now I have been already retried 3 times, 100 seconds apart. I'm still waiting. What do I do now? Right? Now, in such situations, what do we do? This is unpredictable. We tried retries, we tried timeouts. I cannot continue to wait. In that case, there is a technique, we call it graceful degradation. Now what it does is, now perform at least what is bare minimum needed. So think about it. Let's say this service went down, or this went down, or this went down. I said or, not and. Let's say any one of those services went down, since these are different blades. Now, would you agree that in Netflix, when I talked about microservices, there are so many companies who adopted microservices. So Amazon, Netflix, T-Mobile, Uber, Costco, Walmart, eBay, Groupon, all these companies, all these names you must be using on a daily basis now and then, they all are using microservices very heavily. Now, if you noticed here, watch again, is a different microservice altogether, pulling data from some other instance. to find your profile, what you were watching earlier and whatnot. Now this is continue watching profile name, see? It knows the state of each profile in your family, what you started actually, and what you may want to watch again. Based on your choices, it has some intelligence built in it. It will say trending now, other people watching, you may be interested in and whatnot. Think about any of one went down, then what it will do? It will simply replace it and start showing you some different banner. You won't even notice where is continue watching. And after some time, there is a heartbeat back from the service, and it will, at runtime, it will replace that UI for you when you come back. Now that is what we call graceful degradation. The other option to that is, think about it this way. Let's put another example. Let's say you are working on a payment system. In your payment API, there are different payment acquirers. Do you know that? Payment acquirers are who process the payment. In T-Mobile or Amazon, they don't process their own payment. There are Visa, different acquirers who will process the payment, and all the fraud system. All these systems are involved in this, right? Now think about it this way. Let's say there are different acquirers, one for Visa, one for MasterCard, one for American Express, one for Discovery, one for something else. And any companies in the market, to make money, they have even implemented the algorithm to find out which acquirer will process this payment cheaper for me. In T-Mobile, we use that algorithm. We have our own internal proprietary algorithm to find out the cheapest acquirer who can process it faster and cheaper. Now think about it. When UI page renders, it shows you Visa, Amex, all these things. And when it was loading, it figured out my MasterCard API is down. Are you following along so far? Should it not render payment page altogether, or should it say, should not show checkbox or option box for MasterCard, but show Visa and Amex? In today's household, I don't know anybody who does not have all these three cards at least, Visa, Master, Amex. At least two you should have, right? Everybody has it. Even if you don't have it, that's a bummer, but what would you do? Would you stop all rest of the millions of people who might have that? So as you said earlier, graceful degradation is if one service has a hiccup and down, you should not stop entire thing. Rather, you do not show the option for MasterCard, show only Visa and Amex. And let me tell you one thing, many people won't even notice. They are so much in hurry to buy it, they will click Visa, put the number, and proceed further. Next time, another customer comes, service is back, start showing MasterCard option. Now that is what graceful degradation is. Now this is all at a very high level, if it is achievable. Many times, what if it is not achievable? Everything is down. Right? If everything is down, then what do you do? Be honest. This is a real screen from LinkedIn, by the way. So it says it's not you, it's us. Try later, right? So then try later. Maybe there was something wrong and all these things happened, right? So are we good so far? 2-second rule. How many of you know what is 2-second rule? Do you know that? So if you search 2-second rule, 2-second rule is a very interesting thing actually. If you will search on Google 2-second rule, it will take you to your driving safety thing. 2-second rule is a rule that you should maintain a 2-second distance when you are trailing behind a car. If there is a car in front of me and I am behind that car driving, I should maintain at least 2-second distance from that car. That's what 2-second rule is. However, if you will search 2-second rule for web, then this thing will come. This says that most of the user response on web should come in 2 seconds. That's what it is.
I heard it's something like, wait 2 seconds before clicking twice.
Yeah, people do things like that.
Today there is no such thing like clicking twice. Even in one click it already went.
Yeah,
So that time is gone when speed was very low and all, then it was happening, but in today's world, no. It's like swipe. You can swipe to place the order and click and it's done. So 2-second rule is that you need to wait at least 2 seconds when you do things, right? Now what happens in this case is that we want our user, our customers, to have so amazing experience that they do not wait for anything, right? Now think about it. Let's say you go to T-Mobile website, you want to buy a new phone. Now, when you are there and you are planning to buy a phone, do you think we go to inventory, we will check the inventory for you, we will wait for entire credit card payment to come in our bank, and then we say order confirmation? The moment you put your credit card information, your shipping, billing, and all that, like this, your order is confirmed. Right? That is what 2-second rule is. When you go and buy anything from any retail or e-commerce website today, do you know how fast it takes? It goes like that. It's gone. But does it mean it already did all that checks behind the scenes? Answer is no. So how do we do at T-Mobile is, whenever you are placing something, or any organization, not only T-Mobile I would say, what they do is they only authorizes your credit card for payment. But they have not actually submitted it to take that money out. What it does is it locks that much money, it validates you have that money in your credit card, and they lock that much amount. Let's say I'm buying a $1,100 phone from T-Mobile website, my credit card limit is $5,000. Now it will reserve $1,100 on that credit card, send me the authorization code to T-Mobile Digital Payment Services API team, which we have, which is a microservice team by the way for payment, which support payment for entire T-Mobile. And then that team receives the authorization, give it to the API back, and it says, okay, authorized, show the order confirmation, and order domain generates the order number for it. And then in the back end, they start, kicking their legs to find all these things in the inventory, and then SAP is our system for inventory that will talk to the order fulfillment. They will ship the device back to you. When device is being shipped, then our digital payment services team receives a notification from SAP, and then they run the payment, and then we receive that in our bank. So this is the flow primarily at a high level for all e-com organizations. Now, have you ever seen, as I said earlier, and just now I explained you, that not actually your order was checked in inventory? Think it other way. Let's say now you are placing the order. Following 2-second rule, you are buying $1,100 phone, right? And then I say, okay, hold on. I got your credit card information, let me go to inventory, check, do we have it or not? When it is coming to us, let us check it. We are still checking. We are checking. Now response came back in maybe 5-10 seconds. Then we say, okay, we got it. We are holding it for you. Now I say, hold back one phone, golden, rose gold. Now response going back, they said we hold it, again 5-10 seconds, response coming back. Now we go to payment team. Payment, did you get $1,100 in your account? Hold on, we are processing, 5-10 seconds. And then after 5-10 seconds, they are checking back and forth. And now it will take you minimum 20 to 30 seconds if you go all that way. Is there anybody in this room who ever experienced with Amazon or any other provider? I have experience with multiple ones, and that is a good thing. So I know how it functions in the back end. That you placed an order and you later on got a cancellation email. This is my real email from Amazon. So this is exactly on the same stream, on the same spirit as I just explained you. When you place an order, they are not checking an inventory and all, they just have some sort of trust built that once this item is rendering, we have it, we will go to the fulfiller, they will fill it, and again, they only did auth on my Amazon credit card, they did not charge me. They will charge only when it is being shipped from their warehouse, right? And then, after a few days I received this email that, hey, we are canceling your order, you are not charged, we only charge when we ship it. So this is the common industry terminology. What if they could have tested then and there? Then on my phone I would have been holding it like this only and waiting. It would not have followed 2-second rule at all. Today how you order? Swipe. That's how you order. Click. That's how you order, right? Your credit card information is saved in most of the websites. In T-Mobile, we pay discount when you auto pay the bill, right? Your information is already saved in our system. Are we good so far? Did I answer your question about graceful degradation? Now, we did all these things. Now let's talk about some patterns, okay? There are some very cool patterns. It's very applicable to product managers as well. When you are writing specs, make sure you think from that perspective. I'm trying to bring some real world samples here for you. Think from that perspective. I have seen not many technical teams even think that far. When they read the requirement, they just want to implement something. So First pattern is compensating transaction pattern. This is a pretty amazing pattern, very commonly used in industry and very powerful. What it says is, it says that, okay, let's say I am booking a trip, right? You are taking multiple hops by flights and then you are staying in those cities and you need to book room for 2-3 days or whatever, right? Now you book flight 1, flight 2, flight 3. Compensating transaction is, do you know what transaction means? In simplest form, transaction is all or none. That is what the theoretical database terminology based transaction definition is. It's all or none. Means it will either happen all together or nothing will happen. That's why we are calling it compensating transaction. What compensating transaction means is that in this case what will happen is if at any step, as you notice, on each and every step there is a compensating logic. How to cancel that thing means rollback. Right? How to roll back. So I'm booking flight 1, I book flight 2. Let's say for some reason my flight 2 got cancelled. That means cancel flight 2, it got cancelled already, then cancel my flight 1 also. So after step 1, success, if any other step failed, roll back. Make sense? Do you understand that so far? Okay. Now let me give you one real example on the same thing. So let's say there is a situation, we had the similar problem as well, that we had, when you place the order, let's say you are standing in a retail store in T-Mobile. You go and you place an order. Then they wait for the receipt. And let's say for some reason our document management system is down or there is a hiccup or whatever. And that is like few millisecond response we look for. I already told you, graceful degradation, remember that? I am coming to that now again in a real world scenario. So the ambiguity here is many times in our spec we do not tell that how to gracefully degrade. Teams do not ask that question either. They only assume, okay, I will show 500 error, I will show this exception, I will show that error, but they don't ask, okay, tell me one thing, what if watch now service is not responding, what do I show on my UI? I have not seen many specs written in those lines that what should you do in that case, because that is what? Handling failure, handling unpredictability, how to degrade your functionality gracefully, right? Now, what happened is that our document management system or order system had some sort of long queue. It was holding orders to be processed with document management system to receive the receipt. And since the receipt is not coming, API started failing, compensating transaction and order failed. Means I am standing or I am buying something, I am paying you money and you are failing my order. You understand what I mean? Because receipt was not able to be generated and you are in the store. So when we faced that problem, it was running on the similar thing. Why I bring that pattern up is because this is a pattern which industry follows primarily. That's how domains work. One API failed, cascade failure. This is also like cascading failure, right? One step failed, you do things. However, in this case, in our case, failing to receive receipt from document management system should not necessitate the order cancellation. What we could have done is, we could have given them a handwritten receipt. Our UI should have shown to the rep in the store or to the web user that I am not able to generate the order receipt right now for you, but we received it, we are processing it, we will email you later or whatever. So what we did when we failed and we discovered that what is the issue with all these domains, we had a new initiative, we call it change request and a new design and all these things. All the architects got together and thing was there was a change in the backend document management system, there was a change in the order API, there was a change in the UI consuming that API and the change on the wireframes. So what we did, let's start from bottom up. So from the backend, if there is no receipt, for some reason I am order domain itself knows I am not able to generate receipt because I am getting it from somewhere, then send a flag or send me a message with some code that you are not able to generate it. Now my experience API or my microservice is now cognizant of all the codes you are sending me, and each code means something to me, and each code has associated message with it. Once I receive that code, I pass it to the UI, and UI has a separate wireframe ready for you, which says to the rep a message, receipt is not being generated, please give them the handwritten receipt. You follow what I'm saying? If I am working in a company who is a reputed company, how does it matter to me? I already paid you money by credit card, it's already in my credit card, and you are giving me on your printed bill, book, handwritten receipt, I am fine. And even we will email you if you want later on. This is totally fine with me, but I don't want to walk out without nothing in my hand, no confirmation, right? So these sort of things are handled in graceful degradation and not really literally following the patterns as is, like compensating transaction is one thing failed, you start failing everything. Now there is another pattern I want to really talk about that is called bulkhead pattern. Bulkhead. Now bulkhead pattern is about how do you separate or how do you make failure tolerant APIs. Bulkhead actually is a term which came from shipping industry, ships, water ships. Now in the ships, the bottom part of the ship where the skeleton is, which is made up of like steel-like metal, very strong metal, that thing is called hull. That thing is called bulkhead. And how it is designed, it's designed in small pieces, small rooms. So if there is a leak in the ship, only that section is compromised, not entire ship. That is so strong walls between that water, there is no way. Water body is locked in that room. By then they will repair it or whatever can be done will happen.
Didn't work on the Titanic.
So this is, bulkhead pattern talks about being tolerant of failure. And what happens in this case is, in this architecture pattern, when you implement bulkhead, you are locking one thing or the problem isolation within that particular microservice or pool where the resource consumption is more. Now there are a few things which we need to know about it is, now what it does, it prevents against propagation of failure. That's what it does. Now there could be a noisy neighbor situation and then unusual demand. Now let me explain you these 3 bullet points. Unusual demand is, let's say all of a sudden one client receives so many orders or whatever situation, you started receiving so many API calls, so much workload on your APIs. Now that is unusual demand. In that case, it is noisy neighbor situation by itself. Other noisy neighbor situation can happen when for some reason one API service or one client started consuming more CPU resources. Then it is noisy neighbor, which is unusual. And now it is consuming more resources from your machine, and then it can bring entire system down. And that is what propagation of failure is. Think about left part of this screen, microservice, there is one connection pool for X and Y. Now if microservice X and Y both are being reached or approached by the same connection pool by all the clients to your system, and if one service is consuming your connection pool so much, then there is no space left or breathing room left for the other service, and then that is what propagation of failure is, unusual demand and noise neighbor situation. The trick to that is make separate pools for microservices. At T-Mobile, especially in B2B space, we have so many situations where we do bulk processing. We have customers who are spinning lines like, I want to buy 1,000 phones. Apple is our customer, right? Now in that case, how do we meet those demands? We cannot submit, we cannot hold the customer for 1,000 lines. Okay, wait, I will give you lines now. What we do is we take that request and we process it in the background, but we let the customer go. How do we do it? We have bulk processing systems available, which will run it in the loops, because our backend also cannot spin 1,000 lines, let's say. Every backend has its own limit, how many lines they can spin. There is a provisioning required, billing required, and all these systems talk to each other, which I will come and talk next, right? Now in this case, what you do is, for usual demand customers, you give them version 1 of the API, because you are my normal customer, you are like B2C, you are a normal consumer, you can spin maximum 20 lines. Here is API version 1 for you. I give a separate connection pool for that. As you can see here, come to this version of the API and do your thing. Whereas there is an enterprise customer who can always spin 1,000, 10,000 lines if they want. Then we send them to version 2 from different pool, and if there is anything wrong, at least one is not affected by the other. However, as you learn about microservices, the scale, the resource utilization, the resource assignment for one service over the other will be very different because we know what type of customer we are catering. So I was in a design discussion when I joined this team. Team was planning to build something bulk processing and all. They brought to my attention that we already have one service, what do you recommend? And we implemented bulkhead pattern. Because that service was already catering the normal customers. We don't want to disturb normal customers because by allowing traffic for big, large customers as well, so we separate them apart using bulkhead pattern. So if you are doing anything similar or you have done it, you have done a great job, you have followed bulkhead pattern.
Not to mention, you can A/B test that as well, if you need to.
You can do A/B test as well, that also comes, but the problem with that is you don't know. When you, in A/B test, you cannot test the entire load. You only test that how it is functioning. What if somebody say, now I'm sending you 10,000 lines, and then it goes down?
Yeah, at Amazon, they got so much volume coming through, easy time just doing that.
So A/B test is basically about choosing between features. Should I show a drop down or should I show option buttons, things like that, and how traffic is coming, what people are liking more, and things like that.
Yeah.
Then it's good for that. But for such things, I would say A/B testing may not solve the problem what we are trying to solve. However, workload can be tested.
Are you saying that Microservice X and Y might provide the same service just for different types of customers?
That's right.
Okay.
And logic will be different. One B2C customer is sending to the system, give me 20 lines, because in B2C you can have maximum 20 lines. But an enterprise customer wants 1,000 lines.
Yeah.
Now there is a backend system. Backend system cannot take all those 1,000 requests in one time and say, okay, I'm giving you 1,000 phone numbers now. They have their own limit. Let's say they can do 100 at a time. Now what will you do? They don't have the looping logic built in there. Now your bulk processor will do, because they cannot loop in a number of times for you. So they say, okay, you send me request in segments, in small chunks, and we will process it for you. So when we got a request for 1,000 lines from a customer, let's say hypothetically, what your service is doing, X versus Y, is it is looping through the same logic and sending in the small bursts of 100 lines each. 100 lines each. You understand what I mean?
Yeah.
And that was the thing where connection pool and resource utilization and scaling up and down and whatnot.
Is it completely two different systems? I mean that
It could be two different systems. It could be the same backend system, but different aspect, different approach. What we are trying to accomplish. Now, this is another event I have called CQRS. CQRS stands for Command Query Responsibility Segregation Pattern. What it means is, it means separating reads from writes. In any system today, what do you think? What is more, read or write? Reads are always more than writes, correct? In microservice world, this pattern is very, very appropriate and implemented in many organizations, because if there is a customer and then customer wants to see something, then they always go to the read instance of the database, and then if they are writing something, they go to the write instance of the database. In most of the time, the read instance is always NoSQL. The read instance is always NoSQL in most of the times. Now what happens here is, the other advantage of this thing is that what actually you are writing into the system, you are not always reading that back. What you read is a little bit more significantly less than the information you provided in the system. So if you go to your My T-Mobile account today, you are not reading all that information what we have. Or in any organization, any company where you have your account with, right? Any services you take. So what happens here is that you are separating it, and in any enterprise line of business application, what you do is you do CRUD operations. CRUD stands for create, read, update, delete. These are 4 database operations. Create table, you insert into the table, you update table, or you update some row and you delete the row, right? That is what create, read, update, delete called CRUD. CRUD operations are the most important thing. Now, what happens in this case is that, as I said, what you are writing is not always what you are reading. So to have the scale and the load for your system, you always need to think far and have two separate instances for read and write. Now the question comes that how does read know what has been written? Right? Since there are two different databases, first thing is write has to happen, then only you can read. So you wrote it, now how do you read it? So there is an event sourcing. You need an event mechanism in the middle. That's how we have it. Most of the organizations has this thing. Have you heard a thing called Kafka? Kafka is another event messaging system. Now what happens in this case is I'm showing two different microservices here. Focus on the left part only for now for the easy understanding. There is an order service, there is a customer microservice. Think about it this way. So this is order, command endpoint, query endpoint. Means this says post customer detail. This says get customer detail. Are you good so far? One is read, one is write. When it says post, it comes to the command service where you create and all such instances, insert and all those sort of operations are happening. And then you update the command model in your Pojo, Poco, whatever you are using, and it stores the data. And then it publishes an event to the event publisher, and then it goes to the messaging system. So this is also known as pub sub or publisher subscriber model or pattern. So what happens in this case is that there is always a publisher and there is a subscriber. So when you do CQRS, your write instance of the database is sitting on publisher. And then your read has to subscribe to that event. And then only you write once, it says notification, here is the information. Now you go next day, you change your address. There is another event for that, update address. For every single action you take, there is an event mapped, one-to-one mapping between these actions you take. And each event is published into this messaging queue. And from this pool of messaging, the consumer is listening. Consumer means subscriber. Consumer doesn't know, right? It's a push model. And then it listens to it. The moment it receives it, it updates your address in the read instance of the database. So if you think hypothetically that how much difference would that be? Hardly milliseconds. It's real time. It's near real time. It's not like you have two phones open both together at the same time. You say, I did it, not here, because it's coming. Just give few milliseconds and refresh, it will be there. So this is what CQRS is. Now, I have just 3 more slides left, then I am done. So there is something I really want to talk about since you guys are so interested in learning. You must know these things. So there is no such thing in today's world called North Star architecture. Okay? Now there is new thing coming, and I always believed in that, it's called evolutionary architecture. Like, to me, an architecture is always under development. It's a journey. Now what happens here is that we are trying to improvise every single day. As I said, if you are, whatever role you are playing, go back to your system tomorrow and see what opportunities you have to improvise it. At least document it, at least think about it, and then talk to architects and people who are like-minded and share the ideas. Now past is one monolith, like you have one big EXE or web app or whatever. We are way long ago done with that in today's world. Yesterday is you had 2 different systems, back end, front end, again monolith. That is almost done. This is present. This is where most of the organizations are. Even if you are not a small microservice, you have one SOA, but still most of people are in this area, microservices or SOA now, right? Now, what future is that if you see here, monolith front end. This is in T-Mobile. I was architect on the system. We call it Rebellion. If you go to any T-Mobile store, they have one tablet in hand. The system running in that tablet is architected by my team and developed by our team in B2C. We call it Rebellion. And that system is sort of omni-channel. Omni-channel means it's a monolith, the same code base, one code base serving multiple channels. We are in the business where we have web, retail, and care. We have all 3. Now the same system with one code base, we were able to deploy in all 3 systems. What does it mean? How does it know where I am? So when it is loading in the care system, in the header request, it will say I am care. When it is care and you are on the phone 611 dialing T-Mobile Care Center, when they download the payment page, because you are calling to make a payment, in their drop down, they will not see cache option because we know they are care. In web, you will not see cache option because you passed web when you load it in your browser. However, when you open that in the retail, they will see cache option because we know you are running in retail. That is what omnichannel is. Means we build all these APIs, logic and whatnot. Now the future is going towards, we broke only microservices, right? We did not break front end yet. Now the future is micro front end, micro app. At T-Mobile, we are already investing into it. We have huge adoption to it. If you call today the care for T-Mobile, we are using micro front end in care retail already. Now what happened in this case is that you only provide one container, your browser, and the UI loads is just a container like this. In that container, your header, footer, some sidebars and all is the shared real estate, the shared UI wireframes and whatever you are showing on the user experience. However, based on customer journey, you will build a micro app. What is customer journey? Think about like having icons on your phone or on your screen. When you walk in any retail store, you have a purpose in mind. You want to do something. What do you want to do? I want to pay my bill. So we have, that is your customer journey. In a monolith, the omnichannel UI, if we had one single bulky UI as I just explained, omnichannel, what happens is we will search the customer. Correct? We will get a detail. Then we see how much amount due. And then we will load the payment page. And then we will take the payment. How if we trim this whole experience down into just load directly payment page for you? The moment I search you, and you said you want payment, it automatically find all the context and load payment page for you, that's it. And then we take your information, take your payment, and you are done. Now if you want to change plan and services, the same thing cannot do. We need to open another micro front end for you, another micro app for you. What is the beauty of that? Same benefit what you have with microservices. So we took advantage in the microservices layer on the backend side, but now we are bringing that advantage up in the UI layer also. The advantages are same. As you can see, polyglot. This is written in React.js, Angular, or Vue.js, whatever you want, you can do it. And this is how it will look like. So team A owns micro frontend or micro app 1, then micro app 2, micro app 3. Now, as I mentioned earlier about the single team owned service architecture, in here also the same concept apply. One team should own one micro app. If somebody said, okay, team A will own styling of all three, it's not right approach. So don't do it. So avoid horizontal ownership. You need to own the entire stack vertically. Okay? So that team will be responsible for entire DevOps cycle of that, for that customer journey. Now, think about it this way. I will give you one more live example. It will take hardly 30 seconds for me to explain. Now, in any company like T-Mobile or many others, right? There are so many different systems we use. Everybody needs to make payments, right? What if there was one micro app for payment and every application used the same micro app payment? Rather than building their own UI for payment.
Bottleneck.
Right? So think about it that there is only one, like microservice was only one. In T-Mobile, we have only one digital payment services team which supports entire payment for entire T-Mobile. But every team, every application, every UI has their own payment screen. But they are calling at the end, same APIs underneath. Their look and feel is different. But at the end, they are calling the same APIs. What if we had just one micro app, maybe payment team own it or whichever team owns it, and that is standard across. And now I am a screen, I am an app, I'm building an app. Now I just load your micro app in mine, hand off the context back to the UI, that payment done, go process the order, right? So just like little bit work needed for API integration, how do you tell to the UI back, the browser window, that you receive the payment in this micro app before closing. So all those integrations can be taken care of, and in T-Mobile, in B2C and B2B space, we are already using micro front-end concept, this one. So what you do, as I said earlier, this shows in terms of microservice as well, you own the entire pipeline of your system, not just one thing. So you have your source control, whatever you are storing it, you build, test your pipeline, CI/CD pipeline, then you deploy it to production, and then all these three apps will beautifully render together in your UI. So that is, we call evolutionary architecture. At T-Mobile, we are already doing it. And with this, I will thank you so much and thank you for patiently listening. Really appreciate that.
I just have a question on the, go ahead and clap.
Thank you. Thank you so much. I appreciate it.
In the last slide you showed, does that mean that in this case the UI and the front end and the back end, a small portion of it, it's all done as by one team?
Yes. Not the back end,
It's not the back end, only the front end you're saying?
only the front end.
Okay.
Unless it is a full stack team, we call that two-pizza team. When I said single team owned service architecture, it's a two-pizza team. It depends on your organizational structure. Many times it is very hard to find the same dev who can do UI also, and the API also with the same greatness and the engagement it needs, because in my experience, when product or business or analysts give you the customer journey, at T-Mobile we call it customer journey, means what customer wants to do, your wireframes or customer experience, whatever you want to call it. There is a lot of work needed on the UI itself. And then there is the API you have to call API gateway and whatnot, and JavaScript and all these things behind it. And then the API team. So I'm not dictating they should not. So it depends on organizational structure, how efficient you are, and I'm not also prescribing whether they should have it or not. It depends on their accessibility, how wide it is, how Teams has been laid out since beginning. But if they happen to have both, then again it will be micro front-end, microservice, micro front-end, microservice. So they will own entire thing altogether. Yes, sir.
If you can go back to the CQRS slide, that you showed the data store. Yeah, in this one, so what exactly is the difference between the event store and the, so publisher publishes the data and it gets stored in the messaging system. That's where the consumer retrieves the data. And is it finally going to the event store? Is there a single
So
repository?
event store is where your data is going to live. When you are writing it, it will be written somewhere. So it's an event, everything is an event. A customer wants to register, it's an event. So that event data is stored in the database. Call it SQL, no SQL. And the moment it is happening, at the same time, an event is fired. Customer came with this information, right? And then it goes in the messaging queue system. From there, if there is any subscriber, it doesn't know, publisher doesn't know who the subscriber is. If there is any subscriber is listening to that. Subscriber will receive the event, customer XYZ updated. They have their own query, there is a technique, there is a language built around it to understand and listen. And then they will put it in the read storage. Because read is not having any event, you understand what I mean? That's why we are not calling it event store. I think that was the confusion for you. That why that is called event store and not a storage. Because read is not an event, read is just a plain simple read. Now let's say now there is another event coming, the customer wants to update something. Now that information is written here, update event fired down, passed to the queue system, come here. If there is subscriber to that published update event. Now there are bugs in the system as well, by the way. We struggle on daily basis at T-Mobile for all these things. We struggle with all these things. We recently had something, discrepancy in data. Why it is not happening? Because backend was not publishing the event. And it takes us time to figure out. We have so many domains. At T-Mobile we have like 3-4 different billing systems, different payment systems, legacy, which we are planning to retire, building new architecture. So it takes time for you to figure out, okay, now we learned about it. Can you please start publishing that event? And then we start getting in sync. So things will fall apart, of course, the larger the system is, you have more growing pains. So
Question, so when you update your address in your bank account, you usually get a mail in your house telling you, hey, you
Yes.
update your address, so
yes, that's
that's kind of an event, right? So
Yes.
does that mean I'm gonna see an address table in event store, and then I will see a similar table for address in the read storage as well? So I'm
That's right.
seeing
yes,
two similar structures in two
Yes, that's right.
databases. Will that be considered as a kind of like a redundant data with some space?
so it is redundant. You said it just right. But again, as I said, always remember, architecture is all about making trade-offs. It is redundant, but it is not actually and equally redundant. What you are writing in the system is not what always you read. If you go to T-Mobile and you are a postpaid customer, load your profile. Go to my.tmobile.com, you will not see your social security anywhere there. But we have it. You understand what I mean? So if it is two different instances, then what you are reading is much slimmer and thinner version of data than what has been written into it. But you were right, how you receive those notifications is right from the notification system. Something like that is happening. There is a logic API listening to it that sends an email out to you and update your read instance if they are using CQRS. Otherwise, it's all updated here only in one single place, and notification system sends the email out. Capital One uses microservices.
Question. So I understand the backend is microservice, but as the front-end microservice, which is my opinion, is usually the customer only kind of accept one style front-end, right, the UI. So how can, if we go to microservice front-end, how can the user or the different service align, especially the styling things?
Very good question. Did you understand what he asked? So he asked about the styling thing. So it's a very good thing. Manoja, you want to talk about that? We did that Atlas thing in T-Mobile, right? So his question is about if every team is building different micro front-end. Let me bring that screen up and help me if I'm not reiterating your question correctly. So we are doing this, right? So this is the shared, there is a real estate on the screen. So one part of the real estate is static.
Yeah.
So contact us, about us, log in, log out, sign out, your photo and whatnot, right? At the bottom is something. The stored locator we have, map, you can find where the T-Mobile services are and whatnot, right? Now he's saying if every team is building one micro app, how would they adhere to the style?
Sounds like you're in a far, you have an agreement.
So normally we distribute style in the enterprise level. So each it is some sort of line.
Some kind of agreements.
Yeah,
That's right.
it is all legal styles. I cannot put T-Mobile in a blue color. I have to get legal approval.
That's right.
So we say
So-
that library.
So we have a different team which create those assets, and we use those assets to render our UI.
In the end of the day, whole application is owned by one business. So they have to certify.
Yes, sir.
I use, on this slide, you wrote
Which
micro
one?
front end, this one,
Okay.
micro front end slash micro app. So right now there's a, like an app store, Google Play that basically set the rules or guidelines for the apps, for mobile apps, right? So, how do you think, or how do you see the future of this framework would be, micro apps would be forwarding, will it be driven by those market holders or?
Yeah.
who
So
will
not
actually
these
do that?
no, I understand what you're saying. These micro apps are not going to be owned by those holders because we are not publishing it to a Play Store, Google Play Store, or Apple Store. If I'm doing that, that's an app specific for the phone or for all different
So
platforms.
you mean the app, if you talk about micro app, it should be built up somewhere and uploaded into the app store as a single app, so that will be monolithic, if you're looking from the perspective of the app store, right?
Let me give you one example. Do you know that Facebook Messenger is a separate app by itself?
Yeah.
You know that, right? But if you are in a Facebook app on phone itself or in a website, then also there is a messenger. You know that? If I am taking Messenger app outside Facebook app or browser, that is what micro app is. Because there you can do only one thing, you can only message, that's it. So here, first thing to answer your question, these apps, unless a company wants to open source it or make it, I build a payment screen which anybody can use it, then I can open source it. But it's not what you are writing in Angular here can go in a Play Store.
So
But-
there is micro front end.
So don't get confused with micro app with your phone app. Since we have application, micro front end or micro app is just synonym to each other. Think like that.
Okay.
Don't get confused with your app store or Google Play or whatever. And again, These apps are customer journey specific. At T-Mobile, we are customer first, customer focused, and we believe in customer journey. As I said, customer journey is why are you here? When you go to any store, they always ask you, what do you want to accomplish, right? And we want to serve you faster. So when we do these things, all these things are there, and then they say you want to make a payment, click on payment, swipe your credit card, you are done, that's it. And this gives us agility and time to market and speed and scalability and failure isolation and whatnot, because we are now slicing and dicing even our front end into micro front ends. So whatever we were achieving with microservices on the backend side, now we are trying to achieve that with front end and application UI as well. That's the purpose.
What could be the reason that a company stick with the traditional non-micro app mode? Like you mentioned Facebook, which has a separate messaging app, but Instagram has its own messaging staying within the app, right? So with this being the future model of how the front end is designed, what do you see as the major reasons that the company stay with the more traditional front end?
So if you remember, I mentioned at the beginning, one of the pain point of microservices is cultural change. Unless your organization is ready for such architectural roadmaps and enhancements and evolutions to be made, then there is nobody who can push this change, because you cannot do it by yourself. One team cannot function. So if I am a big monolithic or SOA API team, and I say, guys, you know what, bye-bye, I'm making my own API, that's not going to happen. Everybody needs to be on board, then decide who will stay in this team, who will go to what team, hire more people, do whatever it takes to do, but we are going with microservices roadmap now. So it is hard to believe they do not want to do it. It might be in their roadmap, I believe, but not every company is that technically aligned with the new initiatives and evolutionary architecture, as I said. And it's hard to say why they are not doing it. I would say maybe their business model is more like that, which is working fine with them. Hence, there is no hard and fast rule for them that you have to do it because everybody is doing it. Maybe whenever they feel it's right time for them, they should be doing it, I believe.
I think a big one is the kind of the decoupling aspect. I mean, once you get to decoupling, then you can actually section something off and start making progress on it.
Is a key benefit of this though, when you have multiple different types of customers? You mentioned customer journey, where, you know, my family plan is gonna look very different from if I'm buying 1,000 phones, because
Correct, that's
I'm representing,
Yes.
you know, work for a company that's doing that.
Sure.
So I would think that a company that's big enough to support B2C, B2B, and multiple different types of customers, this might be more of an advantage.
So we have, it's kind of not necessarily. So for this, we have done it first for B2C. We did it that first. Because who feels the pain? The regular customer. They are the main consumer you have. However, the bulk is coming from the business side, right? So now in our B2B, we are also doing some sort of inner sourcing where we are trying to look for opportunities where we don't build new UIs. Rather, we look for opportunities if there is a micro app available for the same thing which we want. Let's take it, let's inner source it, right? And then utilize that rather than we build the same UI again. So it also enhances reusability, as I was saying earlier. Think about in your UI, one payment app renders all the time and one team owns it, rather than every team building their own UI to make payment. So that reusability can only be possible when you have a micro app, because it is itself a reusable component. All right. I hope I answered your question. I will be available outside if you need to talk more. But thank you so much once again. Really appreciate your time this evening. Thank you.